Hi everyone, welcome back to our tutorial series. In our previous tutorial, we learned about interrupts, and today we will continue our tutorial series with storage structure, microprogramming, and storage device hierarchy. So without losing time, let's go to our agenda. So in our agenda today, as I mentioned in the topic, we will study 3 different topics, and we hope by the end of this tutorial you will have basic understanding of the storage structure, microprogramming, and storage device hierarchy. Under the first topic, we have the definition, as usual, differences between primary and secondary storage, and types of storage devices and their characteristics. Under the second topic, which is microprogramming, we have microprogramming and its role in computer architecture, microprogramming in controlling the execution of instructions, and lastly we have advantages and disadvantages of microprogramming. Under the last topic, which is storage device hierarchy, we have defined the storage device hierarchy and its importance, different levels of storage hierarchy including registers, cache, main memory, and secondary storage, trade-offs between different levels of storage hierarchy in terms of speed, cost, and capacity. And then we will conclude our today's tutorial. So let's start the first topic, storage structure. What is a storage structure? Storage structure refers to the methods and technologies used to store data in computer system. It encompasses both hardware and software components that manage data storage, organization, access, and retrieval. The storage structure is essential for the efficient functioning of a computer system, ensuring data is available for processing and accessible when needed. The 2 types of storage types, primary and secondary. The primary storage is also known as main memory or internal memory, is the memory directly accessible by the CPU. It is used to store the data that the CPU needs in real time. The characteristics include volatility. Most primary storage is volatile, meaning it loses its contents when the power is turned off. Speed. It's faster than secondary storage, providing quick access to data. Type. The main types are random access memory, which everybody knows, RAM, and cache memory. Currently, my computer has 8 GB RAM memory, and I guess some of you might have smaller or bigger storage memory than the 8 GB. The bigger the storage is, the higher, the more efficient, the more faster the computer works. Secondary storage. It's also known as external memory or auxiliary storage, refers to storage devices that are not directly accessible by the CPU. The data stored in secondary storage must be loaded into primary storage before it can be accessed by the CPU. Characteristics. It's non-volatile. Secondary storage retains data even when the power is turned off. Capacity. It generally has much larger capacity compared to primary storage. Speed. It's slower than the primary storage, and some of the types include HDDs, which is hard disk drives, and solid state drivers, which are SSDs, optical discs, and magnetic tapes. My current storage capacity of this laptop is 512 GB, which is average, and it uses SSD, which makes the computer faster than HDD. Types of storage devices and characteristics, as we just learned, the first one is hard disk drive. It's a magnetic storage. The capacity is high, typically ranging from hundreds of gigabytes to several terabytes. They are slower than SSDs. Um, in terms of durability, mechanical parts are prone to wear and tear, leading to potential failures, and they cost generally cheaper than SSDs. The second one, solid state drives. This is something new. It's a flash memory. Ranges also similar to hard disk drive, ranges from hundreds of gigabytes to several terabytes. Much faster than HDDs. In terms of durability, it's more durable than HDDs due to lack of mechanical parts, and it costs higher than HDDs. Optical discs. The technology behind it is laser rate storage media. Typically ranges from 700 megabytes to 25 to 50 GBs. Slow write speed compared to HDD and SSDs. They are generally durable, but can be susceptible to scratches and physical damage. It costs lower than per unit for the storage, especially for CDs and DVDs. Magnetic tapes. The technology behind this is magnetic storage on a tape medium. It can store large amounts of data. It's slower access times compared to HDDs and SSDs. It's durable. Durable with long shelf life if stored properly, and it's cheaper than optical discs, HDDs, and SSDs. And finally, we have USB flash drives, which everybody is familiar with. The technology behind is flash memory. Capacity ranges from few gigabytes to several hundred gigabytes. The speed varies. It is durable and portable. In terms of cost, it's moderate per gigabyte, with higher-end models being more expensive. I believe everybody remembers Toshiba, Kingston, which were famous types of USB flash drives before other types of storage arrived. I also remember we have clouds, which wasn't mentioned among these storage types. Currently, it's mostly widely used storage type, and some companies are offering the cloud storage for free. For example, Microsoft offers its Drive, OneDrive, and Apple offers its iCloud. There's also Google Drive, which are very famous nowadays. So this was for the types of storage devices and their characteristics. Now we go to our second part, which is microprogramming.